Okay, this is the chapter truss, chapter 6, and we are doing the join method to solve this truss. Okay, so first steps, look for zero force member. Zero force member. Is there any zero force member there? Let's look at this. Here, no, because there's 4. There's never a zero force member when there's 4 members attached to a joint. At this joint, at the joint C, there's 3, and this one is, and there's 2 collinear, but we have an external load. So when there's an external load, there's no zero force member. And same thing at D, there's 2 member, but we have an external load, so it's not zero force member. So zero force member, answer is no. Oh, and we like that because it's easier, but we don't. So now, can we solve at a joint? So let's look at the joint D or C, because that's where we have the external load. So this at D, at this point, we have 2 unknown, and at this one, we have 3. So we can begin by joint 3. So let's do that. So free body diagram at joint D. So that's my joint D. Here we go. That's my known forces, 600 Newton, and my unknown forces, this one and this one. Oh, I put it up. Am I correct? I am correct because this 600 Newton is going to the left, so this one has to go to the right. So that's my FDE. And this one, because this one is going up, this one has to go down. So that's FDC. Okay, so this one means tension, and this one means compression. Okay, we need a direction. So if you look at those triangles, this is 6. So this is 3, and this is 3, and this is 4, and this is 3. So this is 3. So it's a triangle. It's triangle 3, 4, 5 everywhere. So we have triangle like this, 3, 4, and 5 for the slope. So we will use the 3, 4, 5 triangles, and we will use the axis X and Y. So which equation are we doing first, X or Y? We will do X because we know the 600 Newton, and we will solve for FDE using Fx. So sum of the force on X is equal to 0. Give us FDE times, so on X is 3 times 3 divided by 5 minus 600 is equal to 0. So FDE is equal to 600 times 5 divided by 3. So FDE is equal to 1000 Newton. And as we say, it's compression. So this one now, we know it is 1000 Newton in compression. So I mean this one in this direction and this one in this direction. That's your FDE. Yes. And let's do the sum of the forces on Y. It's equal to 0. So we have on Y, we have FDE. So on Y, it's parallel to the 4. So 4 divided by 5. And this one is minus FDC. It's equal to 0. So FDC, it's equal to the FDE, that is 1000. So 1000 times 4 divided by 5. So FDC, it's equal to 800 Newton. And we guess the right direction. So it's in tension because we are pulling on the point. So this one is 800 Newton. And it's tension. So it means it's in this direction and this direction there. Can you see the 800? Here we go. Okay, so we are good with the joint D. Now that we did the joint D, we can do either the joint C or the joint E. If you look at the joint E, we will have 1, 2, 3 unknown we cannot solve. if we look at the joint C, we have two unknown left. So let's do the joint C. Okay, joint C. Maybe I should use another color to write it. Okay, no, that's fine. Joint C. Okay, so joint C is there. So let's do the free body diagram like this. So we have the joint C. We have forces that we know, that's the 900 coming, that the external load. We have the 800 going up because it's tension, 800 Newton, and we have two forces that we don't know, that this one, that is going to the right, necessary, because it's 900, and this one, because it's this one is going to the left, and this one is going down, and we can say right away that this one is 900, and this one is 800 because of this one and this one. So when it's so obvious, like the direction of the force and the magnitude are just like on X and Y, like the joint C, you can just write them. And remember that the force is on the particle. So let's report that on this free body diagram. We found, so 800, 800. So it means that we have 800 also there. And this one to the right, so this one to the left, 900. This one to the left, 900. Sorry for the number 3. 900 here. So now we can go to the joint E because now we have two unknown left only. Okay, so let's do the joint. Let's do it there. Joint D. Joint E, sorry. Joint E. So we have the joint E there. But at the point E, that the 900 that we found, the 1000 on the top, that this one, and this one is 900 there. Okay, and we have a 4 that we don't know. So when we don't know and we don't know the direction, so there and there. Necessarily we have at least one going up, but we don't know which one. So let's put both of them in tension. And that's A, F, A, E. And that's F, E, B. And we need some slope. So we have the triangle 3, 4, 5. 3, 4, 5. And there we have the 3, 4, 5. And symmetrical 4, 3, and 5. Okay, like this. Take your time to draw your triangles. So that's this one and this one, like this. 3, 4, 5, 3, 4, 5. And I remove that. Here we go. So you can't see anything. Oh yeah, because I need to do it like this. So this 3, 4, 5, and this 3, 4, 5 triangle. Okay, and we will use the axis X and Y. I think we will need to solve two unknown. We can do that. Okay, so let's do, so now we are just on this one, on the joint E. Okay, so sum of the forces on X is equal to 0. We have minus 1000 times 3 divided by 5 for this one, minus 900 minus FAE. So this one is times 3 divided by 5 and plus FEB times 3 divided by 5, it's equal to 0. I think we will need the matrix, so let's write this better. So we have minus 3 divided by 5 FAE plus 3 divided by 5 FEB. And this one is 1000 times 3 divided by 5, it's 600 minus 900, so it's equal to 1500. To the right, minus minus. and it's going in the other side of the equal sign. That's my first equation. And my equation for the y, so sum of the forces on the y, it's equal to 0. So I have this one, so I have minus 1000 times 5 divided by times 4 divided by 5 minus FAE times 4 divided by 5 minus FEB times 4 divided by 5 is equal to 0. Okay, you can remove all the 4 divided by 5 and all the minus. Okay, so we get FAE plus FEB is equal to minus 1000. That's my equation number 2. And I use a matrix system. So go on your calculator, edit your matrix 2 by 2, and you will have minus 3 divided by 5, 3 divided by 5. Oops, I did a mistake on my calculator. Okay, so minus 3 divided by 5, 3 divided by 5, and 1 and 1. And the second matrix, the 2 by 1 is 1500 and minus 1000. Okay, and when you solve, minus 1 time, we find FAE. So the first one is FAE. Oops. Oh, let's write it in. FAE is equal to minus 1750 Newton. So it means that FAE, in fact, is going in the other direction. So it should write in this way. So it means that FAE is equal to 1750 Newton. So if it's pushing, it's in compression. And FEB, it's equal to 750 Newton, and we guess the right direction, so it's tension. Okay, so if we go back, so we say this one is 750, and this one is 1750. So if you come back on this one, yeah, I would like to make it bigger, but I need to keep this one. Okay, so we say this one 1750, so same thing there. And this one is it's tension in this direction, and we found 750. So this one is 750, and going in this direction. Okay, we are almost there. So now, oh no, we have all of them. We're good. Okay, so let's just highlight what we found. We found FDC equal 800 tension. We find FDE equal 1000 compression. We find FAE equal this compression, FEB equal this compression, and we need to write that FEC, so this one, it's in compression because it's pushing on the particle. So FEC is equal to 900 Newton in compression. Here we go. Yeah, when it's small, it's too small. So that's the steps. So that's a lot of equation, but it was not so bad. Finally we did one joint, D. So first was the joint D, second was the joint C, and third was the joint E. And we got all our member. So see you in the next video for the little bonus problem. Bye-bye.